Yeah, so we're going to go through kind of the general architecture. Like I said, we're going to kind of step through the layers all the way to the back end, and then we're going to talk a bit about one-to-one-to-one and how to request API changes.
Yeah.
So this is kind of the overall architecture of Expensify. So the flow, which Chirag's going to talk about, but that new dot usually goes through, is you're going to have the app, which talks to PHP, which talks to the backend, and then it goes back. So as you know, because the product that we currently work on is called new dot, that implies that there was old dot, right? So a lot of these things aren't actually currently hooked up to new dot. So for instance, the integration server, that's what talks to all of your accounting softwares, right? So that's going to talk to NetSuite, QBO, all that. That's actually written in Java. That's the only part of our stack that's written in Java. And then we have the scrapers. So that is written in PHP. That is all of our connections to banks and their APIs. And the reason it's called scrapers is because back before banks had APIs, we wanted to still get that data. So what we used to do was have people log in to their bank account. We would encrypt that information, their username and password, and then we would actually log in to their bank with a headless browser, scrape all that information, and then that's how we would get the expenses from their credit cards. We don't do that anymore, as far as I know. Now it's all APIs, which is very nice because it worked, but there were a lot of problems. If they would change where a button is or something like that, we wouldn't be able to get any of that data anymore. So then we also have PDFs. So that is anytime you forward an email receipt to Expensify, it's going to go through that layer, and that's how we parse out all of the data and create expenses. We'll go a little more in depth into Authrock and SQLite, but that is our backend that talks to the database, with SQLite obviously being that database.
All right, and this is a more simplified version of what Brandon spoke about. It's usually ones that contributors or any external developers help us out with new dot will face. And basically we have new dot app, and it talks to our API PHP layer, which then talks to our backend, the auth layer, which communicates with the database. Now, the only thing to think about when you are communicating with our API layer is to know if it's a read or a write request. If it is a read request, you're going to get the response immediately. But if it's a write request, we do a push notification, which goes to pusher, and that sends it out to all devices. So that's the reason why we use pusher, so that if you make some changes, you'll see it on the computer, your phone, iPads, whatever. So yeah, let me go to the next slide. And so for the first area of discussion that I'll talk briefly, very high level about, is the PHP layer. And later we can, if you have any questions for me, you can ask also. Yeah. So if you ever see our PHP code, maybe you'll be surprised. It's not that complicated. It's just this massive if-else tree. It's 3,000 lines. It just says if command 1, we run method 1. If command 2, we run method 2. It's that simple. If someone wants to add a new read or write request, we just do the same thing. We just add another command. It's that simple. And you can see a sample. It looks exactly like this. There's barely any change, except instead of comments, it's calling a method. Yeah, other than that, so yeah, we make, it talks to our auth layer for read or write requests. And this is something important to think about as contributors, is try to think how many read requests you can do before doing the final write request. Because David talked a little bit about this, of how our backend is structured into a follower and leader nodes. So we have one leader, and we have around 7 followers. The one leader is the one that's doing the write commands, and everyone else is available. So 7 nodes are available for read requests. So reads are very inexpensive for us, whereas write requests are a little more expensive. So something we encourage everyone to think about is try to do as many reads as possible to exit early. If you can ever stop code execution earlier, that's really good. So that in the end, we are sure we're doing a write and we do as little writes as needed. So that's why it's a good thing to think about. Just briefly to touch on, we have two ways of returning values for read and write. I don't know if you guys can see this, but this is just a traditional response is equal to an array. And that's what new dot will get if you're doing a read request. For a write request, the PHP is a little more tricky where it sends a pusher notification and it tells what type of ONX method is it, if it's merge or set, etc. And you have to also specify the key and value so that new dot knows how to process it. And another powerful thing about our PHP code base is normally if you've ever seen online, PHP is synchronous by nature, right? But we leverage the power of our Bedrock database and PHP to actually make it asynchronous. So for example, you can actually write code like, say I change my name, right? I want to get the response of me changing my name really fast, but I can have asynchronous code like let all the admins or members, anyone else get that later. So we can process and get that information later. So this way the user gets the response as fast as possible. So that's pretty cool. Also, before you touch the API layer, we also have a thing called the WAF layer, the Web Application Firewall, where we define all our parameters and the data types. So if you ever want to introduce a new parameter, you have to tell one of us so that we can allow it. Otherwise, that parameter won't even reach the backend, which is something to know. Yeah, that's about it about the PHP layer. Go to the next slide.
Yep. So that web application firewall is also like the most common mistake for new Expensify engineers. They might make a new command and they're like, why am I not getting this data? Like I'm sending it. And I think pretty much everyone has done that at some point. So yeah, after the PHP layer is called, we go into auth. So auth is written in C++. It is our source of truth for everything. So anytime we are moving money or collecting money to run billing, anything like that, that all gets done in auth. It has the most robust testing suite out of any of our layers. Pretty much every single command has tests. And the way that we structure that is that each command is its own file. So you'll have a file that's just called add emoji reaction, and that's what it does. And then another file that removes emoji reactions, right? So it's also the main part of our stack that talks to the database. PHP technically can talk to the database, but we really only do that for concierge, and that's very much discouraged. We don't like that. The last thing that's really important is that each of those commands is atomic. So we want to make sure that when we're doing our writes, if we make any changes to the database, we need to make sure that we make all of the changes to the database. Otherwise, it's going to roll itself back so that we don't half finish a command. And that is just really important to make sure that our commands actually did what they said they did, basically. So after auth, we move into the database, which is SQLite. I wrote this slide before I knew that the founder was going to be here, sitting in the back. But we work with them a lot. Pretty much anytime we have really complicated or large queries that we need to optimize or that we just honestly need help with in any way, we'll reach out to their team. They're incredibly knowledgeable. As David mentioned this morning, they've done a lot of custom stuff for us to make it work the way that we wanted it to. But yeah, like David said again, all data is in a single database, which is really, really nice for us to be able to have people connect with each other, to be able to find any user from any user. And again, we built it for old dot, right? So what that's led to is a lot of things that are used for other purposes. So for instance, you've probably seen in a chat, we call them chat reports, and each comment in a chat is a report action. That's because when we built it, that's all it was for. It was an expense report. It was an action on that expense report. And then we kind of realized that, hey, we can do a lot more with this incredible backend infrastructure that we've created. So yeah, some other interesting ones you might hear, name value pairs. That's exactly what it sounds like. It's literally just a name, and so it'll be something like preferred skin tone for emojis, and then an account ID, and then a value, and that's whatever data you want to save in there. And that's how we save like pretty much everything that's related to accounts. That's how we save our policies, all sorts of things. So to go through kind of an example, it's going to be a little hard to see, but the left side here, this is what a report action looks like inside of our database. So we have the created, the report ID, the account ID that created the action, which would be a comment, and then the message. It's called message, but it actually is just a place where we put everything that we want to store. So the database is usually pretty much the same as what you're going to see in Onyx. So the message has edits and a list, and that's going to be in Onyx as well, and then that'll be displayed here as an edit, right? Same thing for reactions. The HTML is just whatever the current text is. And yeah, so that's just an example of how we store every single chat that you send. And also, if you didn't notice, we do actually store all of this in JSON format as a string inside of SQLite. And the SQLite team has written a library for us so that we can actually write queries that can read and edit JavaScript without having to like pull it into C++ and parse it or something like that. SQLite can actually do that itself.
Yeah.
All right, yeah. Pass it back over to you, Chirag.
Yeah, so then finally a philosophy that we're trying to do is one-to-one-to-one. So meaning that for every front-end request that's a new user action, we try to create a unique PHP command that calls a unique auth command. And the reason we're trying to do this is just so that it's simpler on all of us. We have seen people try to add the 15th parameter to an API command, and then that gets so chaotic in the PHP and auth layer where there is a crazy if in the logic, in like business logic, and that gets like so confusing to debug. So like a simple example of this is when here wanted to add emojis, right? We already had an existing command called edit comment and or add comment, for example. So you can add the emoji right there as a new parameter that could probably have been the 10th parameter, but then it just makes code confusing. So instead we would just add something new like add emoji, right? And then it would just make it so much more simpler to debug issues. It's also more efficient for PHP and auth because they're serving a single purpose. They're not doing unnecessary reads on things that's not related to the logic of it. And front-end doesn't need to also mutate data because it gets literally exactly what it needs. Okay, go to the next one. And yeah, as external contributors, if you guys are ever requesting API changes, the first thing to think about is whether it's read or write request because you know it'll impact performance slightly. If it is a read request, you can always test your changes in Postman. And someone here asked the other day, how can we test it even faster? I'd like to work with that person because we could do something like exposing my web, my PHP layer with ngrok, and then they could directly hit my computer and test changes instantly. You don't have to like merge a PR or CP2 staging, like that's not there. You can just hit my computer, test what you need to, make changes as you need, and that's it. For write requests, it's even simpler. You can actually just add it to your optimistic data and go offline, so you can test exactly what you need. And one reason I say this is because I worked with a contributor, and I mean, these are things that you learn, right? So they wanted to know the exact image height and width to render it perfectly in a model. So when they add an image, they wanted the backend to return height and width. And he asked me like, hey, can you return it? So I did return it exactly as he asked me. But then he said that, oh, it doesn't need to be in response, it should be in attribute data. But these are things that you can actually just test in optimistic data by yourself to see exactly if it works the way you want to. Saves both parties a lot of time. So that's an example. And yeah, I think that's about it, actually. Yeah, you guys got any more questions for us? Feel free to shoot.
Question. So in our tables in our database, we have, we're using it like a traditional relational database where we have like primary keys and like specific single values.
Yeah.
And then we also kind of have like a NoSQL approach where we have like a giant JSON blob.
Yeah.
So like what are the advantages and disadvantages of that?
I wonder if, do you want to answer? You might know it better than us. You might know it better than us, but yeah.
One thing is that, they've got, how big is the database file now? 2 terabytes?
Probably, yeah. It's,
Ginormous.
yeah.
You don't want to be adding new fields to a table when a database gets to be that big because you'll break a bunch of other things. But if you've got, you've got your primary, the primary fields that you're using all the time, and then you've got this other kind of miscellaneous over here where you put the drop in JSON. It gives you a lot of flexibility to grow in the future without disrupting other pre-existing capabilities.
Yeah.
Yeah.
And just a little bit to add on to that. So firstly, the question is, is there any reason we would want to save, I guess, JSON blobs versus traditional rows of data? And something that's really powerful with the SQLite team that they've given us is that JSON each is amazing. You can even index on JSON keys. So it's really, really powerful. So sometimes just the JSON data alone that we have, like even in name value pairs, can just index exactly what we want, and it works great. So we don't, I guess this is why sometimes pre-design discussions are so important, because someone will say, oh, let's add a new field or new column in our table, and then we'll discuss it, and we'll be like, oh, we just add a new JSON key, and that's about it, right? So, yeah.
Yeah, I think that's the real answer. It's just that we really don't want to add more rows just because it's really complicated. So we just kind of work with what we have.
Yeah. Yeah. Cool.
So in one of the API files that we showed, we had like a lot of difference you said for
Yeah.
every command. Isn't that inefficient? Like doesn't the last command that you add is slower than the first one?
No, we have not really seen any performance impact at all on it, to be honest. Yeah.
Because if, for example, if you've got like 3,000 and you said 3,000 lines for a contract and you test.
Yeah.
But let's say if it's like 1,500 requests, the first one, to reach the last one, you have to go through the first code.
Yeah. You sort of have to, but I guess I think our servers are so fast that we have not noticed the performance impact, and when we do, we would switch it up. But right now, I guess we're sacrificing having clean, readable code at the cost of performance, because we haven't seen the performance hit. Yeah. Oh, yeah, shoot, yeah.
Right, so you said there's one file C++ to reach your off command.
Yes.
How do you deal with common code that's across multiple off?
So we have tons of library files. Like we have a report.c++ that has tons and tons of utils for everything from adding comments to creating new reports, all that stuff. The auth command itself is just the place where we call each of those library commands from.
Yeah. Yeah, so the question is how do we handle duplicated code? And yeah, just like Stites said, and sometimes we do write commands that have duplicated code by accident, but if we ever find out that, hey, we are duplicating something, immediately move to a utils method so that it's not duplicated. Yeah. Yeah?
Good question. So we have like 1 billion different name value pairs.
Yeah.
Names of name value pairs. And I'm wondering, like, some of them seem very related to like an account. Like preferred, emoji, skin tone, whatever.
Yeah.
Why do we not store that in the accounts table? We use it instead. Like, is there benefits of others?
Well, at least I see an MVP very user specific. And if it is not user specific, then we have report MVP, which is report specific. right? So if we want something else that's not account or report specific, that's, I don't know, contributor is also account specific. If it is purchase specific, then we'd have purchase MVP, you know, we just make a new one. So that's how I see it. But
Yeah, I think I would also add that main value character table was our own archaic version of JSON in SQLite when there was no JSON in SQLite. So main value character is a JSON, which is table.
yeah. Also, did I forget to repeat the question again? It's so hard. Yeah.
I was wondering, what's the difference? I don't know if this presentation covered, but what's the difference between the staging and the production server? Because it's in tables, it's in database.
Yes.
How are they different?
Okay. Sure. So the question is, how is our staging server different than our production server? Well, okay, to begin with, we have 3 staging servers, and we have around 3 staging nodes, and we have 8 production nodes. Production are for users, and we try to never push broken code there. So our first line of defense is we push code to staging. We have all our testers only test on staging, and all our employees, we are told very strictly to only use staging and not production. So this way, if things break, we immediately find it on staging, and we don't move code from staging to production. You know, staging, we go crazy. We break it all the time. I probably broke it on Sunday also. So yeah, we break it all the time, but we make sure that production is as stable as it can be, and that's the difference, basically.
Yeah, and to elaborate on that, so staging is only for PHP and for the React native app.
Yeah.
Auth doesn't have staging. It goes straight to production whenever we deploy it. And as you mentioned, the database is shared. So it hits the same database, it just hits different PHP.
Yes, correct.
Is it possible that something from staging can write something from the database?
Yep.
Yeah, it is possible, yep. Yeah, it's possible. But we're very, very strict with our auth code. The way we review it and test it, it's mandatory to write automated tests. But yes, we screw up all the time. Even without a wrong code, someone would delete a database by accident, you know, so yeah.
Should we create another database for staging purposes only? What's the benefit of doing it that way instead of having 2 separate environments? Absolutely separate.
So the question is, why don't we have a separate staging database? And the answer is we just don't want to put the effort in to do that and maintain 2 separate databases.
Yeah, we haven't seen a valid enough use case where it would be valuable for us, basically. Yeah. Yeah?
During David's talk, he mentioned Bedrock and how it's the foundation for everything. Where does it live in the stack?
Sure. Okay, so the question is, where does Bedrock live in our tech stack? Yeah.
So
You want to take?
Bedrock is over here. Yeah.
Yeah. Yeah. So
It basically, yeah, go ahead.
yeah, it's not really shown in this general architecture view, but in a way, WebRock and Authrock. Okay, so think of Bedrock as our core skeleton. It has very core logic of how like some tokens work, how they're supposed to be read, how they're encrypted and decrypted. But that Authrock and WebRock that you see are plugins that use Bedrock. So yeah, they basically use the Bedrock code, these 2, Authrock and WebRock. And technically, anyone can clone Bedrock because it's open source and make a new something else rock, you know, and it would also work exactly that you want to in C++. Yeah.
is that question, Tim?
Okay, so we got 4 more questions maybe. But yeah, anyone's got any more questions for us?
All right, thank you very much.
Yeah, thank you.